Hello friends, today we are going to start the new chapter in this particular module 1 of computer integrated manufacturing. This one, the computer aided process planning. So before going to start regarding this chapter, that is the computer aided process planning, I want to recap once again what we have discussed in the previous lectures. In the previous lecture, we understand what is the meaning of computer integrated manufacturing and what are the subsystem of CIM, how CIM works and its application areas, that is where CIM is justified, where CIM application is justified economically in a long run. Okay, and this is basically is a long run planning solution where more number of products, more varieties of products with better quality, minimum cost, and within minimum time you have required, then we will go for the computer integrated manufacturing. And CAPP, that is computer aided process planning, is the part of it. So the contents of this presentation comprised of regarding the what is process planning, that is the prerequisites of CAPP, and then CAPP computer aided process planning, then the concept of concurrent engineering and design for manufacturing also you should understand, because with that concept you can understand why the CAPP is highly essential in modern manufacturing scenario. And finally we will discuss about design for manufacturing concept. Here the manufacturing, earlier after design the manufacturing takes place, but in present scenario the concept is changing. Why it is changing? Because to reduce the number of iteration from design to manufacturing department, because after design manufacturing planning start. So if during design we should understand what is the facility process planning, what are the processes, tools are available. That means you should understand regarding the manufacturing systems in detail, then you can take a decision for the design alternatives. From the design alternatives, the best design you can judge, feasible design, and from that you can get the optimum design in a better way. So that is called the design for manufacturability. Here the design for manufacturing means before manufacturing, whenever design has been conducted for a particular product, then manufacturing concepts or manufacturing constraints should be understood by the design pupil, and then this concept will be fulfilled, and also the concurrent engineering concept will be fulfilled. And for that CAPP giving a right direction. Same. Another, finally go for the advanced manufacturing planning. In present scenario our objective or motto is that to reduction of what? Manufacturing support functions. Time for manufacturing lead time has to be reduced. Not only you have to automate the process, but also you have to what? You have to reduce the time for planning the process and time for design. So that's why whenever we discuss about the time for design, then the concept is the CAD. That means with the help of computer or with the assist of computer you can reduce the design time tremendously. Similarly, with the help of computer we can reduce the planning of the process, that is the computer aided process planning. And after process planning, the output of process planning is directly goes to your manufacturing section, that is computer aided manufacturing. So if we'll discuss what is the meaning of process planning, you see that the process planning basically bridge the gap between design and manufacturing. Earlier design and manufacturing, there are two completely island of automation. That means designer, somebody is designing in the computer and somebody doing some manufacturing business using the computer. Here the part programming is has been developed, and here design, job design has been conducted, but there is no proper link, there is no proper integration between design and manufacturing. So this integration is possible by common database and by the use of process planning concept. So earlier process planning basically done by without any computer intervention. That is the manual process planning. How? From the design section, the best design will come to the planning section. Accordingly, process plan will start. And here we have to planning the process, and then it output of that is the root sheet, will send to the manufacturing section for actual physical manufacturing start. So what is process planning? Here process planning acts as a bridge between design and manufacturing by translating the design specification. Design specification means its size, shape, surface finish, its weight, its material, this kind of things. That is the design specification into manufacturing process detail. That is the process planning. So if why you go for the process plan? Why the CAPP is highly essential? Already I have told why it is essential. Because by automation we can automate the physical counterpart. That means the physical physical manufacturing system we can automate. Then your non-machining time, that is your material handling time, tool handling time, it can be reduced tremendously. But if you want to reduce the manufacturing lead time, that is before manufacturing what we are doing, design, process planning, this kind of business, if we try it tremendously, we can reduce by computer, then our manufacturing lead time will be reduced tremendously. So for that, as in modern scenario, computers are developed and is a low cost computers is found with a high efficient low cost computer we have found in present scenario. So companies are try to often use this computer in different purpose. So if they have not used the computer, then what happen? For process planning, for designing, lot of time will be wasted. Not only that, there will be lot of errors because of and it is biased to the knowledge of the expert. Let's say somebody is doing a process plan and another expert is doing the process plan, and this may be vary from person to person, and which is the best you cannot understand which is the best. There is no judgment capability, so it is completely biased to the expert opinion, and there is no that means there is some variation, there is inconsistency in the process plan from person to person. Okay, so traditional process planning where expert knowledge regarding the manufacturing processes involved are highly essential. But in computer-aided process planning, as the softwares are available, only you have to give some inputs and you get the process sequence with root sheet. That means the base sequence you will get with some editing, or in modern scenario fully automated. There is no any knowledge you have required, just you have to answer some question regarding the job surface or job specification, and you get the process plan immediately. So that means how it is possible using the various kind of softwares development. So here expert knowledge is not required, and earlier in traditional there is a capabilities of existing machinery knowledge also important. Let's say you are going to design a process plan without any computer, so you must have knowledge regarding the manufacturing parameters, process parameters, and its conditions, its constraints, okay, how it works, what are the limitations, everything you should know, and then only you can plan properly. But in modern scenario, whatever the data you have found, it is stored in their computer memory, and softwares are there, and they will ask some question and you have to answer just very simple design related, job specification related answer questions, and then accordingly the optimum process sequence will be developed by means of the computer assistance. So that is the computer process planning. So why it is important? To reduce the manufacturing lead time, and in present scenario there is a demand also fluctuating. Today what is the demand of a product, tomorrow it may vary. So because of that, it's fluctuation of demand. Most of the products having fluctuating demand, you cannot predict that in near coming future how much demand will be there. So you cannot take the risk of much inventories of the finished product, and if you store huge amount of finished product, it may not sell. Why? Because technology may change, another company may give better quality with minimum cost, and then your product will obsolete and you have to will out of profit. So that you cannot take the risk, and you go for the batch production, and for batch production you have required some flexibility. So your system should be flexible enough, then only you can adapt those changes. And also you can optimum use of the manufacturing facilities. That means manufacturing facility you can use optimally. Earlier, if the planning and design time will be very high, then that time machine will be idle. That means your utilization of machine. What is the definition of utilization of machine? So machine utilization means actual machine working time divided by the total time. So in that cases, as machine will be idle most of these times because of designing or planning, that means your machine utilization will be tremendously reduced. So if the initial cost of the machine is very high, let's say you are using very sophisticated machine, so cost will be very high. So that cases, if machine will be idle, then your productivity hamper and your goodwill lost, and accordingly your profit will be hampered. So that's why, and the machine will be not utilized properly. So to overcome the difficulties, industries are encouraged to automate the process plan. So not only to automate the physical facilities, but also you have to automate the support facilities. Here actually I am discussing about the process plan. So process plan, you have to automate the process plan. So for that, the computer assistance is highly recommended, right? So what is CAPP? CAPP is a computer program. There is a computer program which automatically generate the process sequence. CAPP basically generate it is nothing but and what is computer program? You know that is nothing but the instructions to what you have to do on the job to get the product. And that, let's say you want to manufacture a hexagonal bolt, so there is a process sequence, first turning, and then let's say at the end of the bolt some thread operation, chamfering operation, cutting operation. Similarly for hexagonal bolt, like using before milling, you are going for indexing operation. So a lot of operations are there. So that operation, if you write on a root sheet, that is nothing but the instruction sheet, and that is developed by the computer program. So computer program nothing but it is the instructions to develop the hard copy soft copy program, right? So CAPP is the computer program which automatically generates the sequence of manufacturing operation. So what is process plan? If anybody, so we should come backward that what actually we understand by a process plan. It refers to set of instructions that are used to make a component or a part so that the design specifications are met. So obviously your inputs are design specification of the product to be manufactured, and the output is the root sheet. And here in the process plan you have to determine how a component will be manufactured, what is the best way to manufacture, that is the process plan, and it is a major determinant of manufacturing cost and profitability of product. So its decision to which process is the best for your product, that is very important. If you by mistake you have chosen a wrong method, a wrong process, wrong tool, then your manufacturing cost will be increases, and then unit cost of particular product will also be increased, and then you cannot fight in the real market because another company given you the minimum cost and it will be out of profit. So what is a process plan? Again I am dictating. Process plan is nothing but a sequence or instruction to manufacture a part as per the design specification. So whenever the design specification comes, and you have to develop the sequence or instructions to manufacture this particular part, and that is the process plan, and which basically bridge between design and manufacturing. In the process plan there are basically three functions we have done. What are the three functions? One is the planning the process. You have to planning the process means you have to decide which process is the best. So planning the process, and then after that you have to determine the cutting conditions or the manufacturing conditions. So parameters, parameter values, parameter range you have to decide. So first you have to judge your process, that is your planning the process, that is the decision to take which process is the best, and then you have to determine the cutting condition, the parameters range, that means parameter which impact on the output or quality of the product. And finally, a very important issue is you have to setting the time standard. That means what is the standard time to manufacture that product, you have to calculate or you have to decide. Why? Because if your standard process plan time is more, then cycle time will be more, then productivity will be reduced, because productivity is inversely proportional to cycle time. So if you can reduce the cycle time, then only your productivity improves. So standard time, let's say a particular a particular expert is giving a standard time 3 minutes, and somebody given 3.1 minute. So 3.1 minutes means 0.1 minutes, indicating your cycle time will be is just 0.1 minute, but if you want to manufacture a huge number of product, then your productivity will be delayed. So that means your cycle time, you have to plan accordingly, that which is the minimum cycle time that giving the better result. So best sequence and minimum set standard time you have to fix. So what are the activities of process planning? You see that there are some inputs in the process plan, and there is some output of the process plan, and there is some mechanisms in the process plan. What are there is some constants also there in a particular manufacturing or production system, in a particular process. So in a particular process planning, what are these inputs? Like design package, means design specification of the product, and industrial engineers also give certain inputs to the process planning, and that means industrial engineering basically that what are the calculations or equation for calculating the time standard. And tool gauge designer also gives certain, this is the if your job size is like that, and this type of robot or this type of gauge, this type of cutting tool is recommended. So as per your job, the tool and gauge designer also inputs are giving. And obviously a knowledge, that is your manufacturing process knowledge also is required for that. So if in a modern scenario computers can do this by some reasoning activity, if you properly write a program, this program will understand and program will run, and program is basically developed from the knowledge of the expert. So expert can understand, and from the expert opinion the programs has been developed. So as per this program is nothing but from the knowledge the program is developed. And the layout, that is your facility layout, means where which machine is there, that you also the input of the process planning, because a particular small company, small space is there, and as a large company is a large space may be there. So if the space is large, in that cases, or machines are positioned in distance from each other, then your material handling time may be more. Where in a small space a lot of other problem may be there, like material handling problem, jamming problem may be there, but the material movement distance will be less. So facility layout also giving the inputs, and these inputs, and what are the other inputs? What are the inputs? Other inputs are intelligence. That means some intelligence means if any problem occur, like tool broken, or like some let's say cutting fluid is not coming, this kind of thing. So what action should be taken immediately? So this also has to be embedded in the program, that if this happen, what action to be taken. Okay, and time, how much time is required, or the part programmers also given certain inputs to the process planning, because part program is the part programmers also given some input to the process planning, that if this is your job, this will be the proper part programming sequence, and there is a process planner. So these are some mechanisms, and there is some constants. So constants in terms of layout, in terms of intelligence, in terms of you may say that is design package or the part program. So these are some constant where which type of software, which type of hardware you are using in the system, in the computer system or in the manufacturing system, this may be the constant, and a particular mechanisms will be there. So as per the inputs, what will be the also mechanisms is also important, by which the inputs are from that output or machining operation plan can be developed, right? Now coming to so what are the basic processes involved in the process plan? Okay, so what are the basic process steps? First you should analyze the part requirements from the from the engineering drawing, and then you have to select the workpiece, which type of raw material is required, then determining the manufacturing operations, and their sequence, then selection of machine tool. So as per your manufacturing operation and sequence, you have to choose which type of machine tool is recommended for you. Let's say for cylindrical job you should prefer this lathe machine. For pile whip job we should that means non-cylindrical job, we should prefer milling or shaping machine. For hole making operation you should prefer the drill machine, this kind of thing. Surface finishing you are preferring grinding machine, this kind of thing. So selection of machine tool. So after selection of machine tool you have to select the cutting tool, what will be the tool material, tool geometry, this kind of things, and accordingly what type of forces is developed. So then tool holding devices and work holding devices, inspection equipment, that has to be judged. And finally you have to determine the machining condition. That is very important, that machining condition means during machining what will be the cutting speed, feed rate and depth of cut. If we give an example of any drilling, machining or the milling or turning, there is a cutting speed, feed and depth of cut you have to maintain, and then only a particular surface finish, surface roughness you can achieve. And finally very important is the manufacturing time, because manufacturing time is the cycle time. So cycle time is inversely proportional to the productivity. So and it combined of setup time, processing time, lead time to manufacture. So these all time you have to calculate, and that is how much setup time is required, how much processing time, that is manufacturing, actual manufacturing time, and the setup time, that is non-machining time during in manufacturing in the machining system. And also you have to calculate the lead time, that is before manufacturing how much time is required. Okay, so basically what are the activities? Again I am recap once again, that study of the overall shape of the part. So first you have to classify the part, what type of part, it is cylindrical or non-cylindrical, is detailed dimension, and then determine the workstations required, and then analyze the part requirements, part surface requirements, tolerance, surface finish. You have to decide which is the cutting tool for machining condition, and select the raw material and base shape to use, identify the reference surface of jigs for setups, a reference surface also to be developed, and select the manufacturing operations, grouping the manufacturing, select the manufacturing operations and grouping and sequence you have to judge. Select the jigs picture and select the inspection machines and determine the cutting condition, and then final process plan you can get. Okay, and for that what are the methods are available, I am coming. Before that examples are giving what are the basic process plans are there, like casting, rolling, forging, extrusion, secondary process like machining, and the property enhancement like heat treatment operation, and the finishing we can go for different coating operations. So these are the process sequence, that means primary, secondary, tertiary and final. So and you can choose from the available processes. For single operation, in case of assembling station, this is somewhat different, sequences are different. What is the difference? For single station, the documentation contained a list of assembly steps in order to which they must be accomplished. For assembly line production, basically you use the line balancing method to balance the line. That means for assembling case, let's say instead of manufacturing we are assembling a automobile. So how the assembling is done? So in the assembling case basically we are controlling by line balancing method. Here instead of manufacturing, just assembling takes place. Okay, and there is a assembling method, means there is which are the robot and what are the assembling stations are there. So for as with the process planning for individual parts, any tools and fixture needed to accomplish a given assembly task must be decided and the workplace layout must be designed, right? Now for example, let's say we are going to manufacture this particular job, here you see that some lot of operations are there, and for that this is the initial job and this is the final job you have to manufacture, and lot of operations there. Let's say slotting operation, sampling operation, threading operation, turning operation, different kind of operations we have required here. So in that cases, process planning, how we can do it? Process planning is defined here. It is a systematic determination of the detailed method by which workpiece or parts can be manufactured economically and competitively from initial stages, that is raw material form, to finished stages. The activity of developing such a plan is called the process planning. Okay, so what is process planning is clear, and geometric feature, dimension, size, tolerance, material, surface finish are analyzed. Geometric feature means a size, shape, dimensional sizes, and the geometric features, tolerances, material, surface finish analyzed to get the appropriate sequence of material. So to decide which is the process sequence. So accordingly, final process plan is nothing but a route sheet. Earlier, whenever computer is not there, this process plan is developed manually, operation description, and in which department you have to perform, like lathe, drill, mill likha hai, and there is a machine, which machine out of this department, which machine name is given, which machine or code is given, and this machine are used, which tool are using, and what are the setup time and what are the standard time, right? So this setup time and initial setup time, because whenever we go for a batch production, we have to set up once and then you manufactured huge number of or particular batch of production. For that each product, how much time? Let's say here 5.2 minutes is the standard time, whereas the setup time is around 1 hour. So this is the process plan or route sheet. Is then after this sequence, the second sequence, after lathe is go to drill, then go to mill, and then corresponding. So this is the route sheet, and this route sheet directly sent to the earlier, whenever computer is not there, whenever route sheet will be developed, the route sheet directly sent to the manufacturing section. Here foremans are there and they will instruct the labor how to do and how to, and from that they will understand and they will proceed as per the route sheet. So route sheet is nothing but the document that specifies this blueprint of success from the process planning department. That is the output of process planning is the route sheet, and the route sheet is to the process planner. What is the engineering drawing is to the product designer. Route sheet should include all the manufacturing operation to be performed on the work part listed in the order in which they are to be performed. So responsibilities of the process planning part. Earlier, whenever computer is not there, what are the tasks of the process planner? A part print analysis and symbols. That means from the engineering drawing he should understand the part print analysis, symbols, gathering the fundamental detail of the product design, then selecting the machining process, selecting proper machine tool, operation sequence, and also the design, deciding about the which are the inspection for quality control, inspection, and then quality control. You have to judge which are the equipments you should use, and appropriate tolerances, determine the appropriate production tolerances, that means measurement, and then proper cutting tools and cutting condition, calculating the overall times or standard times. So these are the responsibility of the process planner, and this without computer, manually, pen paper work you have done earlier whenever computer is not developed. So before going to discuss about the computer aided process planning, we should understand we should know about the knowledge regarding, we should have minimum knowledge regarding the concept of group technology. Why group technology? Because to automate the process plan, there is a high impact of the group and technology concept or group and technology philosophy to the process planner. What is this group technology? Here actually we are grouping the similar kind of jobs. Why you are grouping the similar kind of jobs? So that the process planning will be easier. Let's say just for example, a cylindrical job go to lathe, and non-cylindrical job go to milling or shaper. So how will decide? That means we have checked whether it is cylindrical or not, and if it is cylindrical it goes to lathe. Okay, so that means we are grouping a cylindrical job one side and non-cylindrical job in another side, and then further we can group what is the L by D ratio of the cylindrical job, then this goes to this lathe machine, and if L by D ratio is more, then it goes to this lathe machine. So lathe machine also may be smaller lathe to heavy duty to light duty to heavy duty lathes are there. So then accordingly you can get the best machine for your product. So that means if you can group the job as per their similarity in their shape size, or if you are grouping the job in terms of their manufacturing similarities, then the process planning will be very easier. Just for example, already I have told, right? Let's say you want to get a very good surface finish where tolerance should be very minimum as possible, and where in a particular case the tolerance are very sometimes the tolerance will be required much more. Okay, so so what is the responsibility is clear, and a group technology concept is that you have to grouping the similar jobs in terms of their design similarity, manufacturing similarity, or both, so that we can easily process plan will be easier. So it is the exports the part similarity, right? And here, and accordingly after grouping the jobs, if a particular group of jobs, let's say having some similarity in their manufacturing or design, they can be manufactured in a particular cell. What is this one? I mean to say that after grouping the job, let's say this kind of cylindrical jobs will be manufactured in this kind of machines. Let's say these are the machines, only let's say 3 or 4 machines are required to this a group of family jobs. Group family means one particular group having some similar jobs. So all are cylindrical, but material may be different, its size may be different, but can be manufactured by the lathe section. Let's say lathe section having different lathe machine, out of 10 lathe machine only 3-4 lathe machine is required. So if these 3-4 lathe machine we are separated from other lathe machine and we are making a cell, then what happened? Let's say this group of jobs will coming to these 3 machine only, not move to the other lathe machine. But if all the, let's say 10 lathe machine I am positioned in a particular place and jobs are coming and lathes are randomly positioned, 10 lathes are randomly positioned, then material movement may be increased. And this material movement if increase, then non-machining time increase. So but if I grouping the machines, that is 3 or 4 specific machines which are mandatory for the manufacture of particular this part family, then we can say this is a cell, manufacturing cell, and from that the concept has came cellular manufacturing. So cellular manufacturing can be implemented by manual automated method. Here machines are grouped into cells and each cell specializing in the production of a particular part family. For example, you see earlier in traditional process layout, all lathe machine, here पे use the turn all lathe machine in a particular place, that is the lathe section, all mill machine in a particular place, that is the milling section, all drilling machine in a particular place, drilling section, and grinding and so assembly. And you see that the arrow, what is the arrow? Let's say one jobs are processing like this, this is the arrow, and then this goes to this arrow, and then after turning they go to milling. Okay, after milling the job, let's say this job is finished, another job, so that means here pe job is finished, so then this job has to be moved over here, another job, let's say it is moving like this, here and then here, then here. Some jobs are moving like this, you go to there and then here drilling, and after drilling let's say grinding, and after grinding let's say assembling, and so on. So and if we measure all the distance of the arrow, that is nothing but the total distance moved by the all the jobs in the system, that is the total material movement distance, or which is nothing but the total material movement time, or sometimes maybe overlap to each other, but the distance is clear that how much material is moved before manufacturing. But if we group it in a proper manner, that means like this, let's say here one turning machine, one milling machine, one drilling machine, which are specialized drilling and milling and turning to manufacture a particular part family. Similarly, these 3 are position in as close as possible, so that here milling, drilling and grinding, these three machines will be responsible for another part family to manufacture a particular part, another part family, and then assembling each of them and getting the final product. Then you see that your arrow distance is reduced tremendously. What we have done, instead of all the lathe machining a particular place, I have positioned one lathe here, one lathe here, one lathe here, not instead of 3 lathe in a specific place. Okay, so by means of which the distance of the arrow, that is the arrow distance, we can reduce drastically, that is your material movement time reduced drastically. And that means we are making the cluster of machines, just like we are grouping the jobs. We have to cluster the machines to manufacture a particular part family. Part family means same type of, similar type of jobs which are grouping earlier. Okay, and one particular cell is called the manufacturing cell, and the concept is called cellular manufacturing, and the layout is called the cellular layout. You know about the process layout. This is called process layout, and here this is the hybrid layout or group technology based layout. So each cell specializes in production one or more limited number of part family, so by which we can reduce the cycle time tremendously. So that means the concept of cellular layout and the concept of part family, concept of group technology is helping in the process planning to be easier. If we have not process planning using manufacturing cell concept, then what happened? Material movement, non-machining time, material handling time will be huge, and because of that your cycle time will be much more. So if you want to reduce the cycle time, then you have to design the layout, that means position the machines in a particular section, so that the material movement will be minimum, and this concept is called cellular layout. Okay, and this group technology concept, this cellular mechanism, this cellular concept is highly recommended or highly used for process planning to be easier. If you are planning like this, then your process planning also will be easier, because a new part whenever come for the process plan, then just you say, okay, this is similar to which part family. Let's say there are 10 part family, out of that number 5 part family it belongs. Then number 5 part family, what is the process sequence and what is the cell is responsible, in that cell you can send this new job to manufacture. Then process planning or will be very much easier by the planner, because this particular cell is already given that means a particular cell is governed by a particular management pupil, and accordingly if similar type of job will come, he can decide how to manufacture very quickly. But another part family, it goes to another cell. So that is the concept, so that it will be very easier. So group technology concept is applied to automate the process plan also. I'm coming to that. So what is why you go for the computer aided process planning? So during the last several decades, there has been considerable interest in automating the process plan function by computer system, because earlier only we are automate the physical system, but we have to automate the support system. Support system means design, process planning, manufacturing, these kind of things. So shop floor knowledge, shop people knowledgeable in manufacturing process are gradually retiring. That means without much expert, you may not develop the right process plan in right time. So that's why we are we try to take the assist of the computer, so that it will be very error free, and the best one process plan can be developed, and there is improvement in the consistency. That means if you run several times, the best process plan will come. All the time the same process plan will come. So an alternative approach to process planning is needed, and computer process planning provide the alternative. So manufacturers have been pursuing an evolutionary path to improve the computerized process planning in the following 5 stages. There are different methods are available. Which are the methods? That means the methods are improving day by day. Earlier only manual classification or standardized process plans are available, and a new part will come. Then from the standardized process plan, manually we are retrieved and then edited, and then computer maintained or computer managed process plan. Here there is a database we have developed, database we have managed, and database for let's say database for the process, database for the machine, database for the cutting tool, and a new job will come. Then after checking the similarity of the job, which kind of which group of family, and then again manually from the computer we are retrieve a particular file for the choosing the process, and then a particular file for choosing the cutting tool and sequence, and finally another, let's say, file for calculating the time standard. So that means here computer is here, but computer management just to store the files, and managed by computer will manage for storing business, and operator will retrieve the data or retrieve the file whatever is required, and then accordingly the process plan is developed. So the stage 1 and stage 2, this is the primary methods where just computer is developed or where computer has not developed at all. And then in the stage 3 and 4, basically whenever due to development of computer, low cost, high efficient with minimum response time computer whenever developed, then this variant CAPP and generative CAPP has been developed. And variant CAPP basically is basically is working on the principle of group technology. So group technology highly directly help for the process planning by using the variant process planning or retrieval process planning, and whereas the generative process planning is a completely fully automated, and here are some reasoning, reasoning, there is some knowledge based reasoning question we have in inbuilt in the program, and the question will be asked by the program to the operator, and just operator will answer the questions. Let's say first question, it is cylindrical or non-cylindrical. It is a yes. If it is yes, then what is the L/D ratio? You give this in. What is the material? It is ferrous or non-ferrous? And if it is a ferrous, then what is the carbon percentage? This kind of thing. So if you answer all the questions, then process plan automatically develop. So that is called the fully automated generative process plan. And the future prospect is a dynamic generative CAPP. The research is going in that field, so that any variation of the job design in a certain point of time, the automatically the program also will be program also will be updated, and accordingly the best CAPP will develop. So first stage and 1 and 2, it is prior to CAPP, manufacturer attempted, it is here written that manufacturer attempted to overcome the problems of manual process planning by basic classification of parts into families and developing somewhat standardized process plan of parts families. So particular part family, similar jobs, one standard plan. Second part family, second group of similar jobs, another standard process plan. This is the standard process plan. So already you have developed and you have stored it earlier in a hard copy document. Modern scenario, whenever just computer came, it is a computer storing devices. So when a new part was introduced, then the process plan for that family, then is first you have to judge this new part is belong to which part family. That means what similarity with which part family its similarity is there, and accordingly would be manually retrieved and then marked up and then retyped or edited. That means it is also time consuming process, because only computer will managing the storing issues, and then you have to edit, you have to retrieve and then edit it by the operator. So it is quasi automatic. That is 1/4 you may say that is a automation, about 75% done by the operator. So while this improve productivity, these two methods are improve the productivity, cycle time is reduced slightly, but it did not improve the quality of the planning of the processes, because there is and it did not easily take into account the differences between parts in a family. Okay, because standard process plan is there is no if the new part has came, the new process plan will not develop. So that's why there is no improvement in the quality of planning. Slight improvement in productivity, but quality of planning is not somewhat improved. And nor improvements in production process. Okay. Now with the variant process planning in the stage 3, the initial computer aided approach evolved into what is known as the variant CAPP. What is variant CAPP? Variant CAPP is based on the group technology, already I have told. It is basically the coding and classification approach. Whenever a new job has came, you have to code it, that what is the L by D ratio, if it is cylindrical, then what is the weight of that, what is surface finish tolerance, these things, and accordingly a number or digit is given. Let's say just like a roll number of a student, you have to given a code, just like whenever we code the electrodes in a welding, arc welding, how the coding we have done. So the coding, all the informations are hidden here. So here actually through coding, why you are coding here? Because if the computer system, the coding is helpful for searching that which part family it belongs, and from that it can easily retrieve the standard process plan similar to that means for same part family, and then accordingly you can edit it very quickly. So these attributes allow the system to select baseline process plan, that is your standard process plan for the part family, and accomplish about 90% of the planning work, and then you just editing 10%. Okay, and the planner will add the remaining 10% of the effort modifying the fine tuning of the process plan. Here some knowledge is required, not a heavy knowledge or depth knowledge is required, but some knowledge is required for the editing purpose. So it is not also a full automatic. Around 90%, 70-80%, 90% is done by automatically. 10-20% you have to done manually by the operator. So operator expert knowledge is here also essential, and is also the consistency is not very good, because it may vary from person to person for the editing action. Whereas final one, that is the generative process plan and dynamic generative, here what is, it is a completely automatic system, automated process plan. The next stage evolution is the generative process. The process planning decision rules are built into the system, and these decision rules will operate based on the parts group technology or the feature technology coding to produce a process plan that will require minimum manual interaction and modification. Just you have to enter some answers as per the questions from the program will come in front of the operator, and you have to just answer the question, and accordingly the process plan will be developed very quickly. Okay, so next so what are the activities of process plan? Again I recap once again, what are the activities of process plan? Because now we are going to discuss in detail about the computer aided process planning. Just we understood what are the methods are there, and also we are grouping the methods. One is quasi automatic, one is semi automatic, and one is full automatic. And if we want to discuss in detail, before that we should understand again what are the activities. So far we have discussed the activities in terms of an example. Here it is in a block diagram. It is clearly understood that what are the process planning activities. First we have to analyze the part requirement, that means your jobs part requirement means what type of surface finish, what type of tolerance you have required. You have to analyze it. Then you have to determine which operation sequence is best, and accordingly you have to decide which are the machines are required, and then cutting tool required, and then you calculate the processing time, and then you have to process plan document is prepared, and then finally you can send to the manufacturing section. So in the next class we will discuss the detailed process planning activities and the role of computer in each section of the process planning activities in the next class. Thank you.